Hello participants, welcome to this lecture 2 of week 6 for our course Metrics and Analytics of Marketing. In this week we are discussing a important concept related to marketing metrics and analytics, which is about predicting and combating customer churn. In today's lectures we will try to look into 3 aspects of predicting customer churn. Basically, first we will try to understand what are the various signals of customer churn. I mean, what are the precursors of this churned customers? Then, what are the various models, statistical and others, through which we can predict the customer churn? And ultimately, what are the different ways through which we can try to evaluate and validate the customer churn models, right? So, let's start with the basic understanding of what is the main goal of prediction of customer churn. As we know, all of us know that the ultimate goal of analyzing and understanding the customer churn is to improve the profitability for the organization. But there are two main outputs associated with how can we predict and analyze the customer churn. One is, first thing, we need to identify who are the customers who are likely to churn in the near future. This likelihood is dependent on the probability of churn, and we term them, let us say, if they are in the top decile of in terms of probability ranking of churn, then in that case they are the high risk customers. First we need to identify who are these high risk customers. Second thing that will help us understanding the entire phenomenon, understanding the combating strategies for churning customers is unearthing the underlying reasons, underlying drivers behind this churn. Why the customers are leaving the brand? Is it because of increase in price? Is it because of there are abundance of products from various brands which are probably superior to our brand's offer? Is it because of our some lacuna in our customer service? Is it because of some product quality related issues? Or is it because of customers are forgetting the renewal of our product, or something else? So, we need to understand why the customers are actually churning, and then only we can take any proactive strategy so that we can prevent them from churning with a limited cost which will be lower than the expected profit, expected value that will be generated by these customers over the period of time of its lifespan with the brand. So, this is the ultimate prediction goal. It is divided into two outputs. One is understanding who are likely to churn, and another aspect is why the customers are churning. Both these outputs are equally important. Now, we will look into the first aspect of today's discussion, that is the signals associated with customer churn. As we know that customer churn is a human behavior, right. So, any human behavior is actually preceded by a number of sequence of events. So, if something has happened, there is a possibility of happening something else. I mean, X leads to Y, something like that. So, there are some antecedents associated with customer churn. So, these signals can be captured in a model. So, if we can identify these signals, then it will be easier for us to identify who are the customers who are likely to churn, and accordingly we can go into details why they are churning, and accordingly we can take the intervention so that we can prevent them from churning, right. Effective churn prediction relies on identifying the key behavioral and demographic indicators that signal a customer is likely to leave. Two types of phenomenon that we are looking into. One is the behavioral indicators and another one is the demographic indicators. Behavioral indicators might contain, let's say, usage pattern. Let's say I have been using a product 10 units per month from last 5 years, and suddenly I mean reduce the usage to 5 units per month. Now then there is a possibility that gradually I am trying to reduce the uses of the product. So this is a signal that in a future, at a future point of time, I am going to churn from this brand or product category. Similarly, there can be demographic indicators like what is the age of the person who is using it. For example, some of the products are related to let's talk about a product which is for young people. So over a period of time, let's say the person becomes a bit older, then in that case that product will be no more of any use for that person. So in that case the customers will churn, right. So all this phenomenon needs to be captured. The signals, some of the signals that is identified by various studies are, first one is the usage pattern, like how the customers are using the product. Are they heavy users, are they medium users, or are they light users? Then you can also look at customer support interactions. Is there any surge of complaints about the customer care, about the customer service of the brand? Is there any unaddressed refund or not? So all these things, all these metrics will give you a lot of indications regarding what is going to happen to the customers. Recently Indigo has come up with the crisis. Basically there had been a lot of issues, and probably they can definitely predict that if so many complaints are coming from the customers, then in that case some of them will definitely churn unless and until a proactive action is being initiated. Then we can also predict some of the churn from the contract and billing data, right. So for some of the customers the contract cycle is getting over, let's say in the next month. So renewal is a uncertain phenomenon. So whether the customers will renew the product usage or not, and that can be captured by the usage rate in the during this contract period. So if usage was at a higher level, then probably the person is likely to renew it. Otherwise, if usage was at a lower level, then the person may stop using it, stop renewing it, right. Then similarly the demographic and profile data. Demographic data is something like the age of the contract. Let's say if it has been for 10 years and let's say the average age of a customer relationship for our brand is 10 years, then in that case the customers are likely to leave our brand in the next year. Similarly, some profile related data, right, some other profile related data. So age of the person, then gender of the person, then income of this person. So all these things will come to play when we predict the customer churn. So before actually analyzing this customer churn, we need to define the prediction target. Remember that everybody will have a positive probability of churning. Only thing is in place is that what is that probability? Is it 90%, 80%, 70%, or just 2%? And another aspect is like the time frame. When are they likely to churn? So depending on that, the kind of intervention that we are going to take needs to be prioritized. For example, I will probably initiate the proactive actions on a priority basis for those customers who are likely to churn, let's say in the next 30 days. So we must have something like called level window. So who are the customers with a high risk of churning in the next 30 days? Who are the customers with a high risk of churning in the window of let's say 30 to 60 days? And based on this, we will set the priorities. Basically, the observation window, in order to predict the churn in the next 30 days is the features from the last 60 to 90 days. One caution that we need to take while we are analyzing the customer churn in this direction is that we should not use any post scoring or post churn information to make our model free from any biases. If we take the post scoring data or post churning data, in that case the model will be influenced by this data point. So, that is why we need to take the decided data only. Now comes the features categories, right, the signals associated with customer churn. The first one is the uses. First category is about uses patterns. We can get a lot of indications whether a customer will churn from the brand or not depending on the usage behavior in terms of recency, frequency and monetary use, like we discussed in case of RFM framework. What did we say in RFM framework is that if the person has recently bought the product, he is likely to buy the product again in the near future. If the, on the other hand, if the person has not bought it the product for many days, many years, then in that case he or she is likely to not buy the product. So, this is nothing but a churn. Customers have not bought, a person who used to buy the product, let us say at a frequency of 30 days, have not bought the product for 60 days, the possibility is that the customer is likely to churn, right. Similarly, we can also consider the some of the commercial decisions as indicators of churn. Let us say I am operating in a price sensitive segment and suddenly due to some input cost I have to increase the price of the product. There will be some customers who will churn from our brand. Then if I am reducing the extent of discounting, then in that case there will be some customers who will churn from our brand because they are basically the discount mongers. Then regarding the services, if you can see a lot of complaints regarding your product or service, if you can see a lot of returns of your product or service, if you can see a lot of refund requests for your product or service, then in that case, yes, you can expect, you can anticipate a surge of customer churn in the near future, and that is why it is time for you to take the proactive action so that you can prevent some of the possible churns, right. Then from the engagement also, engagement metrics also you can have a lot of indications regarding the probability of churn. Let us say email open rate. So, if it is reducing drastically, then you can definitely presume that customers are no longer interested with your brand, that is why there is a possibility of churn, right. Then if there is more payment failure, system related failure, if there is card expiry that is happening, then in that case you can expect that the customers will churn. Then another dimension of customer churn indicators are from competitive landscape, which region you are operating your business in. So, let us say if we talk about the technology, internet technology, it is always advanced in the western countries as compared to eastern countries. So, let us say if we talk about 5G technology, which is relevant in India today, but over a period, shortly it may become irrelevant in the United States or other western country because they will upgrade themselves to 6G, right. So, in this way, depending on the region, the customer churn is likely to happen. The example that I have cited, that in US shortly the customers might churn from 5G products, right. Then it is also dependent on the category, and it is also dependent on the availability of substitute, like the rules of economics. If there is more substitute in the market, more substitutes are emerging in the market, in that case you can consider that some of the customers will churn. So, one of the example of churn risk rule is that customers inactive for more than 45 days with a sharp decline in usage should be classified as high risk customers. This is thus a rule of thumb. You can customize this rule depending on the product category that you are dealing with, depending on the market segment that you are dealing with, right. So, but you have to definitely have to start from a rule of thumb. Now, next comes the second dimensions of our today's discussion, that is the various models of predicting customer churn. Till now, we have discussed regarding the signals associated with customer churn, the indicators of customer churn. Now, we will be looking into the various models that can be used to predict customer churn. The simplest form of model is the rule based method, which use the simple threshold technique to assign probability, to assign whether a customer is likely to churn or not. There is statistical model such as logistic regression or machine learning based model such as tree boosting, random forest, to determine whether a customer is likely to churn or not. And there are some survival models which determines not whether the customer is churning or not, but also what is the point of time when the customer is likely to churn, right. So, let us quickly discuss about each of this model one by one in brief. So, let us start with rule based method. Rule based method means it contains some predefined rules regarding the customer churn predictions. The rules will be pre-decided based on the expertise. So, we will take the expert opinions like what determines the customer churn. Let us say if the expert says that in this particular set of product, especially for Indian market, if the customers have stopped purchasing your product, let us say for last 30 days, then the customer is a high risk customer in terms of churn. If the customer's frequency of purchase is decreasing, then the customer is likely to churn. If the customer's quantum of purchase is decreasing, then also customers will churn over a period of time. So, from this expertise, from this expert opinions, we will frame a rule, right. So, common rule based threshold can be all these three components of RFM framework, that is recency, frequency and monetary value. Another dimension in which we can set a threshold is the contractual status, whether it is an active contract or it is likely to, it is nearing this expiration. So, depending on that we can assign the likelihood of churn for that particular customers. Then we can also try to predict the customer churn based on the behavioral trend. Let us say last 5 months or last 6 months moving average transactions amount for a customer. If the last 6 months moving average transaction amount for a customer is decreasing from last, let us say 10 quarters, then in that case we can fairly assume that the customer is a high risk customer. So, this can be seen from the purview of behavioral trend as well. When we talk about this rule based methods, rule based models, various characteristics are basically it is transparent. It is not like a black box machine learning model. It is easy to understand by the managers because the rules are very easy to comprehend. So, based on these rules the decisions are being taken. So, everything is more or less transparent, right. So, it is done with a deductive approach rather than an inductive approach, because the rules are framed from the expertise. That is why it becomes transparent for the customers. Another characteristics, or in a way I can also term it as a limitation, is that it is very static. The moment the rules are predefined, it is not updated based on the changing environment in the market conditions. So, this is a static model and it can give you a high false positive results. False positive means basically it gives you, the result will be like kind of masqueration of being a churn customers where the customer is actually not churning. So, the impact of false positive is something like that, the customer would not have anyway churn, but you have invested unnecessarily on the interventions, assuming that customers would be churning in absence of any intervention. So, this is just an additional cost for the company. Now, next statistical model is about logistic regression. Logistic regression is something like it is not actually a regression. It is close to a classification problem. So, as we know that in case of linear regression, the dependent variable has to be a metric variable, like either it has to be of interval scale or it has to be of ratio scale. But what happens, let us say we are predicting something whether the customer is likely to churn or not, means churning or not churning. So, these are two categories that we are dealing with. So, this is more like a classification problem. We, based on the input attributes, we are deciding whether the customer is churn customer or churning customer or non-churning customer. In this case, what can be done is that, as this is a categorical variable, a regression model cannot be applied here. Now, what can be done is that, because if you look at this nature of this problem, it is not also about whether we have already decided the customer will surely churn or the customers will not surely churn. Rather, what we are trying to talk about is like, what is the probability of the customer being churned and what is the probability of the customers of non-churning. So, we are basically dealing with something called a probability, and whose value will be a continuous variable that lies between 0 and 1. So, that is why we invoke another model which can take care of such kind of a problem, which is called a logistic regression. So, output value of logistic regression is the probability of a particular category, probability of churn and probability of non-churn, right. So, this can be captured under logistic regression. This is the working principle or working genesis of logistic regression. So, statistically it is easy to explain to the management because it talks about the probability of churn. That is what the management needs. If the probability of churn is more, let us say I am categorizing the customers based on the probability of churn, then in that case let us say customers who are having a probability score more than 0.75, I will categorize them as the highest risk customers and I will take the interventions accordingly. So, this particular modeling is good for starting and governance because it is easy to explain, is it easy to comprehend, and nowadays with the emergence of lot of statistical tools and techniques, we can just input the data and try to get the output in terms of probability of churn. Fine. Next one is something called tree. This is another machine learning techniques. So, tree is basically a technique in which we route to a decision or we navigate to a decision through something called nodes. So, one node is nothing but a variable. So, there will be a defined range of the values of this variable, and based on that either we will go to the left side or we will go to the right side, right. So, this is something like it works under something called information gain. Let us say I can see that if the customers are coming from the hill stations, the customers will not renew the subscription. This is just a hypothetical example. Then in that case, I can directly add a variable which says that region, hill station or plain station, right. The customer is from hill station, if the answer is yes, the customer is not renewing. So, there in this case we are getting a 100% information. All the customers who are from the hill station, they are not renewing the subscription. But it is not always 100%, sometimes it can be, let us say 80% of the customers from the hill stations are not renewing. So, still we will put them as, I mean, we will directly not end up in a decisions, rather we will take them towards another decision variable. If the customers are from hill station and the customer is a male member, then the customer is churning. So, from hill station it will not directly come in a decisions, rather it will come to another variable. That is, if the gender of that person is male and he is from hill station, then in that case the customer is churning. So, we try to navigate to the decisions through certain variables which are considered as nodes, and these nodes are set the priority, which node should come first, which node should come as a root node, and which node should come as the second order second level nodes is decided by the amount of information gain. Amount of information gain is nothing but the probability of certainty. Let us say if all the customers from the hill station are churning, then we are 100% sure, but if it is 90%, then information is 90% only. So, my previous case, the information gain is more than the latter one. So, what do? We do the time based splitting. Time based splitting means we split the data into, let us say, two categories. One is the training data, another one is the testing data. So, we try to build a model out of the training data and then try to test the model based on the testing data, whether the model fits perfectly or not. When we talk about tree, it handles the interactions automatically. This is a good thing and positive sign of this machine learning model. But it needs careful validation and monitoring, because we are just giving directions to the, we are showing the navigation part to the decision. So, in this case it is always prone to overfitting. So, decision trees are basically prone to overfitting. So, to overcome this problem of overfitting, we can rather than creating one tree, we will bootstrap the entire data point and then probably create multiple trees from different data instances of this available data set, and then take the average of this all the trees. Like we will fit our new instance of data into all the available trees in the random forest, and the majority, the decisions related to the majority of the trees in the random forest will be considered as the final decision. So, this solves the problem of overfitting. Now, let us talk about this training and validation speed. So, what do we do? Basically, how a statistical or machine learning model is built? We must have data in place. So, we do not use the entire set of data for modeling, because we need to check the robustness of the model, and that is why what we are going to do is, like, we are, let us say 75% of the data will be used for building the model. So, once the model is built, then we will consider this remaining 25% of the data and try to check whether the model is working fine or not, whether the accuracy associated with the model that is built from this 75% of the data is working fine for the 25% of the remaining data or not. So, if for most of this 25% of the data the model is working fine, then we can say that the model is generalizable and it has a better robustness. So, what is the suggestive actions in doing this split of training and testing data is that train on the older months, especially when we are looking into customer churn phenomenon, and validate on the newer months. So, if we do that, it prevents the future information bias. So, we are building the model based on relatively older data and then checking the model based on relatively recent data. In that case, if it is working fine, then in that case we can fairly say that this model is robust and it can be extended, it can be generalized. Then let us look into the validation and evaluation metrics. So, how can we validate the model? As I have said that in order to validate the model, I need to divide the data set into training data set and testing data set. If the model that is built out of the training data set is working fine for the testing data set, then we can say that model is valid, right. So, this is the simple working principle of model validation. So, one technique that is used for model checking the model validation is the confusion matrix. Confusion matrix is nothing but from the model that is from the model that is derived from the training data set, we will input the testing data set and we will see whether it gives a true positive value, false positive value, true negative value or false negative value. True positive means the model is also it should be predicted as churn and the model is predicting it as a churn. True this one, false positive means the model is not predicting it as a churn while it is actually a churn. Then similarly, false positive is this one, true negative is the model is predicting it as a churn, but actually it is not. Then false negative is basically the model is not predicting it as a churn, but at the same time it is also not a churn. So, we do not have any problem with true positive and false negative, only problem lies in these other two components, that is false positive and true negative, right. So, in one case we are predicting somebody who is not likely to churn as he is churning, and in another case we are actually not predicting somebody as being a churned customer while he is actually churning, right. So, this is kind of a type 1 and type 2 error, like rejecting a true null hypothesis or accepting a false null hypothesis, fine. So, we need to understand the sensitivity of this type 1 and type 2 error in our context, and based on that we need to decide which one is acceptable, which kind of error is acceptable, and based on that we need to do it sensitively. Then comes the various metrics of evaluation. One is the AUC. AUC means area under the curve. So, this determines what is the probability of you being correct. Then accuracy. Accuracy means if you are predicting somebody as churning when the customer is actually churning, then you are moving towards accuracy. Similarly, sensitivity. Sensitivity, as I have discussed, it is more like the ability of the model to consider all the customers who are likely to churn as the churn customer. Then precision is like whether we can precisely predict it or not. So, this is a combination of accuracy and sensitivity. Then we talk about the validation of the model. So, validation can be achieved through cross validation. Cross validation is nothing but dividing the data set into training and testing data set, keep them separate so that your testing data set is actually not influencing the training data set. Then only you can fairly check the robustness of the model. So, now regarding this explainability, why customer, why this customer? So, one is it provides you with drivers. You can find out or you can diagnose the drivers, the usage drop, the complaint spike. Whenever there is a usage drop, whenever there is a spike in complaints, whenever there is system failure related to the payment, whether the customers are only buying, whether you can actually observe that the customers are only buying when the discounts are in place, then in that case you can fairly predict that these are the indicators that we need to take some interventions. Output of this model should guide the action, not just the score. If I get a score of probability of churn for each of my customers and let us say I am not doing anything, I am not taking any initiative, then in that case it is of no use. Let us have a look at a small kind of caselet, and which is about predicting the churn in a subscription app. The context is a subscription app aims to reduce the monthly customer churn. The current churn rate is 10% per month. The prediction goal is to identify the customers likely to churn in the next 30 days. First thing that we have to find out is that what are the key signals. Days since the last login or usage, change in weekly usage frequency, then payment risk such as failed renewal or card expiry, and service related issues such as the support tickets and low satisfaction scores. Basically, we are looking into various key signals which indicate that the customer is likely to churn. Then we also need to have a look at the model, statistical model. Begin with the simple statistical model, which is the logistic regression, for a clear interpretation, and we can validate the results using the time based data split from the testing data set. The highest risk 10% of the customers show a churn rate of 30%. Highest 10% customers show that 30% risk of churning, which is 3 times higher than the overall average 10%. Let us say for the average customer, the probability of churn is just 10%, but for the highest risk customer, it is 30%. What is the action rule now? Intervene only for the highest risk 20% of the customers who are also of high value to manage the cost and improve the returns. So, what was the outcome of this particular initiative? The targeted outreach and payment issue resolution reduced the churn in the treated group from 30% to 22%. Most of the retained customers were those affected by the payment related problems and declining uses. It is not related to service quality. So, if we can identify these things, what is the leading indicators of this churn, then we can take the intervention accordingly. Remember that we will only take the intervention when we feel that the cost of the intervention is lesser than the benefits associated, benefits associated with preventing the customer churn, right. So, thank you for today. I will conclude this class with a statement that churn prediction is only valuable when it turns into timely targeted actions, otherwise it is just a score. I will see you in the next class.